Hello everybody, this is Miss Redmond here with you today. So please open your workbook to page 216. We're working lesson 4.4. Page 216 for lesson 4.4 if you're not already there. So our learning target for today is to use the distributive property to expand an expression. Okay, and you've actually done this before. So as we're doing these problems, hopefully it looks familiar to you. But we need to first review what the distributive property is. And so here's the example. If we have some number or some term outside of our parentheses and it's being multiplied to something inside, like b plus c, then we have to multiply that term or number to each of the terms inside. So we have a times b plus a times c. An example of this would be if we have 5x or 5 times x plus 2. So that 5 is being multiplied by the x and it's being multiplied by the 2. So 5 times x, we get 5x plus 10. All right, so let's start with example 1. A family farm plans to add a blueberry patch to the end of their apple orchard. What is the total area of the land that will be covered by the blueberry patch in the apple orchard? So we know a few dimensions here. We know the width of the orchard and the length of the orchard and the patch. So I'm going to go ahead and represent this down below here with 2 rectangles. Okay, so let's see. We'll do a blue for the blueberry patch. So this isn't going to be quite the same shape as what they have here, but we still get the same idea. Okay, and then we have the apple orchard. So for blueberry patch, we know that this length is 1.5, and this is in kilometers, but I don't really need to put that in my diagram here. Oh, you can't see that. Let me scoot that up. Okay, and then we know, let's see, the width we don't know actually. So I'm going to call that B. For my apple orchard, we know that the length is also 1.5. It has the same length as the blueberry patch. So I could say this is 1.5 as well. And the width, I don't. Oh, no, actually I do know. It's 2.5. Okay. So there's kind of 2 different ways I could think about this. Either I could figure out what's the area of the blueberry patch and what's the area of the apple orchard, and then together know, or I can find what the total area is. Or I can draw a diagram that just represents all this land that I have for my produce. And so if I use these dimensions, let's see, my width, or my length, whatever you want to call it, doesn't really matter so much, is 1.5, and my length here is going to be B plus 2.5. That's the total length. Whatever this length is plus the 2.5 kilometers. So now all I have to do is find the area of these rectangles. So something I have to remember is that area is equal to length times width for a rectangle. So if I want to know what's the area of the blueberry patch, I'm going to take 1.5 times b. I could say 1.5b. If I want to know what's the area of the apple orchard, I could take 2.5 times 1.5. And if we multiply that, then we'll get 3.75. For this rectangle, again, I'm taking the length times the width, so I'm taking 1.5 times b plus 2.5. Because I'm multiplying by all of this, I need to put that in parentheses. So I can represent the total area either by saying 1.5b plus 3.75, or I could represent it with this expression, 1.5b plus 2.5. And these areas should be the same. So let's make sure that they are. And what I can do here to see if these two expressions are equivalent to each other, remember I have to use one of my properties. And here I can use my distributive property because I'm multiplying a number by some terms in the inside of a parentheses. So let's start just with that expression. And let's use the distributive property. 1.5 times b, just 1.5b. And then I'm taking 1.5 times 2.5. I'm going to put that in parentheses, that way we see we multiplied by this and multiplied by that, and then add them together. So here again, we just get 1.5b, plus 1.5 times 2.5, we get 3.75 again. Notice that these two expressions here are exactly the same. That means this expression is the same as this expression. So we can solve for this problem using either method, but at the end, this is the most simplified expression because it's expanded. We don't have like additional parentheses we have to work with, so it's kind of nice. I think this looks nicer myself. All right, why don't you go ahead and try it. Complete the try it right down below, and then we'll go over it together. Okay, so let's look at this problem together. I'm going to kind of ignore this diagram at first and just kind of focus on what this problem is saying. What's the expanded form of the expression? If this helps you, go for it. If this is confusing to you, you don't need to worry about it, okay? If you're a visual learner, maybe this is helpful. But the important thing is that we can distribute an expression. So we have 3.6 times t. So 3.6t. Then we have 3.6 times 5. 3.6 times 5 is going to give us 18. And then we can carry down the 3.6t. So our final expression here is 3.6t plus 18. So if we look at this diagram now, we have 3.6 is being multiplied. Remember, if we want to know the area, we want to take the length times the width. So we're taking 3.6 times t, and this must be the 5 then, because this entire length then is going to be t plus 5. So again, this is, and we're just multiplying these two together. And whatever is here is in parentheses. You could say this is in parentheses, but we don't really need to say this is in parentheses because we're just given that one term. Okay, so we multiply that together. That gives us this expression. And then our final result here, the area of this rectangle is 3.6 times t, or 3.6t. And then 3.6 times 5 is 18. So the total area here is 3.6t plus 18. And that's this right here. Okay, let's go on to example 2. I'm going to scoot this up a little bit. Okay, so example 2, all we're doing here is just practicing using the distributive property. So we're starting with this expression. I'm just going to rewrite it. This one's kind of special because we have this x on the outside this time instead of Last time we had 1.5, so we have a term now instead of a number. But the process is exactly the same. Before I get started, though, I'm going to start by rewriting the subtraction as adding the negative. It just helps me keep track of my signs. So I'm going to write this as negative 1.5y. That negative belongs to the y. So I have to make sure to keep it all together. Okay, and we could say the same here. That negative belongs to the 2. So when I multiply x times my first term, I'm taking x times negative 2. Okay? And I know this might seem a bit excessive with the parentheses, but I just really want to make sure that I'm understanding I'm not taking x minus 2. This is still multiplication. X times negative 2. Now then here, again, I'm going to be multiplying x times negative 0.15y. And then I add these two terms together. Okay, so negative 2 times x is negative 2x. Negative 0.05y times x. This is just all being multiplied. So this is negative 0.5x times y. If we multiply two terms by each other, x times y, that's just xy. I don't have to write the multiplication anymore. I could, but I don't have to. Here, all these terms are being multiplied. Let's just focus on this part because I really want to make sure everyone's understanding why this works out so well for us. So we have negative 0.5 times x times y, right? These terms are all being multiplied. Here's just another way of writing it. Well, let me actually write it so it looks the same format as over here. So I have x times negative 0.5y. All these are being multiplied by each other, right? Even the negative 0.05 is being multiplied by the y. So here it doesn't matter with multiplication the order. I could write this as negative 0.5 x times y, and I don't really need the parentheses because the parentheses tells me to multiply, but if I don't have them, I'd also know that negative 0.5 x is negative 0.5 times x, and if I put y there, I'm multiplying by the y. Alright. So if you still have questions about this, when we come back after the Ed puzzle, please ask. Alright, it's really important that you're understanding that all this is being multiplied and those are different ways we can represent it. Okay? Alright, so if we come back here, guys, we're done. This is our final answer. So there's nothing left for us to do. Here's the expanded expression. And notice here we can't combine these terms because here we have x and here we have xy. All right, now you try it. Let's try it. All right, so let's go over this one together. So we have t times negative 1.2w. Again, that negative goes with the 1.2w plus t times 3. That's my second term. So I multiply these together. I always want to start by writing my coefficient in front. Here, this number goes in front of my variable. So I'm going to write this as negative 2.1 tw plus, I could leave this as t times 3, but that looks really weird to me. So I always want to remember to write that number in front of the variable. So there's our final answer. All right, one more example that we're going to do together. One more try it, and then we're going to bring it back together as a whole class, okay? So, again, all we're doing here is we're multiplying negative 1/3 times each term. So, we have negative 1/3 times 2 plus, and again, I want to think about this as subtracting, adding the negative. So this is going to be negative 1/3 times negative 3 plus negative 1/3 times 3. So from here, you guys are good, right? We've done this. Negative 1/3 times 2, negative 2/3. 1/3 times 3 is 1. And then we have, right, because that would be 3/3, so we get 1. And then we have a negative times a negative. That's going to be a positive. So here we get positive 1. And then we have, okay, 1/3 times 3 again, that's going to be 1. But we have a negative times a positive. So this is going to be negative 1. Hey guys, did you catch my mistake? Hopefully you're paying attention. This is actually negative 3x. So when we multiply here, we should get 1x. Hopefully you caught that. All right, so now we're going to combine like terms. So we're taking this a step further than the last one. We have an x, but we have two constants here. We have two numbers. We can go ahead and add those together. So if I take negative 2/3 plus negative 1, that's going to be negative 1 2/3. And here we have x. So x minus 1 2/3. Or you can write this as 5/3. We could also switch the order and say negative 5/3 plus x. Any of those options are okay. In your book list, all of those. All right, now let's try it. Your final answer for this one should be negative 4 plus negative 6m plus 8n. If you'd like to go over this one together as a class, just let us know. All right, guys, best of luck. Great job. Keep up the good effort, and I'll see you guys later.